this is going to be the first lesson on the blueprint system. We are doing this as kind of one of the first lessons you should do because blueprints are kind of pervasive throughout the engine. Um, Almost all subsystems of the engine use some form of blueprints to communicate and do logic. So it's really important to have a strong like fundamentals in this and like understand the concepts really well. So this is part one. There'll be a part two for kind of more the advanced stuff with blueprints. So this is more just an introduction. So the pre-lesson material, we had you guys watch the Blueprints Basics playlist. We thought this does a good job of just a very fast crash course into kind of the stuff that you'll find in most programming languages, and just to see how that's done in the blueprint system. I think it's also important to see this because obviously like blueprints is a visual programming language, and I think most people probably would not have ever done one before this. I know I had never really even like heard of visual programming. So I think it's important to like have seen that and see like you can do all the stuff that you can in like a normal programming language with like loops, conditionals, all that. It's all there, and it's just good to see that. And then these next two, the triggerable light and pickup object, we thought those were just good uh, examples of like showing what you can do with blueprints more than just like the concepts of like the programming concepts. And we thought that whole playlist was really good. I think in the next part we have you watch another video from there. But if at any point you want to do more stuff or learn more, we think doing all those tutorials and watching those in that playlist would really help out. Cool. So I think, yeah. You want to take this part, Ben?
Sure. All right. Start.
Yeah, so just for this one, we're going to kind of do similar to what those videos were. We're going to go through like how to open a door. Ben's going to show you that. And if you have any questions at any point, just stop us and let us know.
Okay, can you guys see my screen?
Yeah.
Yes.
All right. Okay, so starter content. So if you're creating your own project, just make sure you check that starter content. Or if you forgot to, an easy, quick way to do that is just by clicking this little green Add New button, Add Feature or Content Pack, Content Packs, and then Starter Content. This comes with a bunch of different materials and some static meshes and all kinds of like props and stuff like that for you to just kind of help make a simple project. We're going to be utilizing the door and the door frame static meshes inside this content pack. I already have it here, but so door and door frame. So the first thing when we're utilizing static meshes in Unreal is we need to make sure that they are going to be doing exactly what we are expecting them to do in terms of collision and gameplay. Because sometimes when you import your own static meshes or you're getting static meshes from packs, they may not always have the collision or some of the assets that you are expecting them to have. For example, I know from experience that this door, if I opened it up, this is the asset editor window and preview. And essentially it shows you different things like how many triangles and vertices that this door is made out of, if it has any LODs, what textures and or materials are being applied to it. But we can also check things like the normals, and most importantly for this example is the collision. So we can click this little green collision box and select simple collision. And if there was collision on this object, it would display in kind of this green cube or whatever around the object. And I can show that by going to the door frame and showing that. So you'll see these green like cubes around here. So for whatever reason, this door doesn't come with collision built on. So what we need to do is add that really quick, or else there wouldn't be much point of a door if you could just walk right through it. So to do that, we can just go to this collision tab, and we can add box simplified collision. Now, depending on the different shape of your object, you could try some of these other ones. But one of the really cool things with Unreal is if you choose one of these simple collisions, it will try to shape that collision around your object. So you can see by just adding that collision, I didn't have to really adjust anything. It just kind of fit the shape pretty well. But if I wanted to adjust it, I could just select that collision by left clicking it and then just manually tweaking it like I would any other asset. Okay. So now that we have both of the collisions working well, this is something just to keep in mind when you are creating things like arches and door frames and stuff like that, because sometimes when you import an asset that has kind of this empty space in the middle, a lot of times it will kind of fill that in with a collision box. So you wouldn't actually be able to walk through it. But that's just something to keep in mind. Now that we have the
shortcut keys, that the WER ones still work in the asset editing window? Or?
Yes, they do.
Okay.
That's a good question because there aren't any buttons up here to tell you, but yes, you can select things. And then if you select the collision boxes, same thing, W to move them, E to rotate, R to scale. Now that we've got that, essentially what we're going to do is create a blueprint that houses these two static meshes. And then we're going to use what's called a timeline to animate one of those static meshes to open the door when you get close enough to it, and then close it when you get away from it. Exit my filter here, and I'm just going to create a blueprint of actor class. Call it BP door. Another thing, whenever you see this little star next to an asset, that means it hasn't been saved yet. So there's some sort of change, or it's been created new and it hasn't been saved yet. So as soon as you hit save, that little star will go away. That's the same thing with the map as well. And in order to save the map, you can either go up here and save current, or you can hit save all and it'll save everything in your project. Okay, so once we're in our blueprint editor here, we're going to add those two components that we're just talking about, the door and the door frame, to this blueprint. So we're going to add static mesh in the component tab. We're going to call this one door. And then we can select that one, and then you could hit Control W, and it will duplicate that exact static mesh. And then we can just call it door frame. And then we can change what static meshes these are. So over on the right side, under the static mesh tab, in the details panel, we can type in door. That will be our first door. We have door frame. Now you'll notice that the pivot point of these two objects is slightly different. So the pivot point for the door is on the bottom left corner, whereas the pivot point for the door frame is center in the middle. So that's really important to know for whenever you're adding in assets to Engine. It's something to just think about when you are importing your assets, to try to keep a consistent pivot point. That way there's less hassle on you on the Engine side trying to fix that. So in this case, since we didn't import this asset and this is already built in here, we're just going to have to adjust this by moving it. But after we've done that, the next thing that we're going to want to do is create a box collision component. We can do that by just going to add components again. You can either scroll down to the collision section, or you can just type in box collision. And what we're going to do is, that's another thing to remember, is whatever you have selected, when you add a component, it will parent whatever object you're just adding to that previous thing you had selected. So if we were to move this door, the box would go with it, as you can see here. In our case, we don't want that to happen because when the door opens up, we want to make sure that that collision box is still in the exact same spot that it was when we first entered it. So we want to make sure that it's not parented to the door. But I'm just going to drag this out here, make it a little larger. And we will call this open door box. Okay. So when you have components selected in the components tab up here, in the details panel, if you scroll down, it will give you all these different options for events that you can do with that specific component. So in our case, ones that we really care about here are the on component begin overlap and on component end overlap, because we're going to be essentially checking to see if someone, the player, walks through this collision box. And if they do, then open the door. And after they stop being in the collision box, then we want to close the door. So you can either press this little plus button and it will create an event in the event graph for you. Or you could just select your open door box here and then type in on component begin overlap, and you get the same thing. But what we're going to do now is add a timeline. Typing in timeline will be add timeline. We're going to call this open door. And an important thing to understand when we're working with timelines is why we're actually using them. Typically, when you're doing animations inside of Unreal, you are using skeletal meshes or things that are being animated in real time, essentially, based off of joints and bones. But when we're using static meshes, those don't have bones. And so you can't animate them in a typical fashion. And it's cheaper to animate them using timelines than to import them in as a skeletal mesh with physics assets and stuff like that. So essentially, timelines are used for animating static meshes, whereas your typical animations are used for animating skeletal meshes. But to use the timeline, we're just going to double click it. It'll open up this blank window here. And up in the top left hand of this window, there's a bunch of these different add nodes where we can add different types of tracks based off of what types of values we're wanting to adjust and animate over time. For the purposes of this, we're just going to use the simplest one, which is a float track, which is essentially just a single value track that we're following. Okay. So this is what's called an animation graph. And this is going to look really similar to other programs like Maya or 3ds Max that have animation suites as well. But essentially, it is a graph that has a horizontal and a vertical axis. The horizontal axis in this case is time. So you can see our length here is 5, and this is 5 seconds. And so you can see it goes from 0, 0.5, 1, 1.5, etc., all the way to 5 seconds. If we adjusted this to 2 seconds, then it brings down that timeline to 2 seconds. So anything that's highlighted here in this kind of light gray or lighter gray is what the actual animation track is. Everything outside of this will not be used. So that's just an important thing to remember. To get started with the animation track, you can right-click anywhere in here, and we can add a key. And this means we're going to add a keyframe to a specific time. So right now, wherever you right-clicked is where it'll create it. So it's at like 0.08 value, like 0.28. We can just select that keyframe now, and we can zero that out to 0. Essentially, what we're going to do is read in where the door currently is, and then just adjust its relative rotation based off of the value. So we have our first value, which is 0, and then we're going to have a second value, which will be our turned value. So we're going to put this at 2 seconds, and for the value, we're going to put 90. So essentially, we're going to turn the door 90 degrees. Now you'll notice that when I put that up to 90, it kind of like shot way up in the air and we can't really see it anymore. So one of the things that you can do is if you adjust it really high like that, you can click these 2 buttons here, zoom to fit horizontal and zoom to fit vertical. And it'll reframe your animation graph based off of the values you have in there. Okay, so now that we have the basis for our timeline, we can actually go about setting it up here and utilizing it. So the first thing, now that we have our timeline, is we want to be able to check to see that the correct thing is triggering the door to open. And this is important because right now, if we were to just plug this in, anytime anything overlapped that door hitbox, it would open the door. So potentially, if this was like colliding with another door, or if this was colliding with the floor, or like some actor that was on the floor or something like that, the door would just continually try to open. So what we're gonna do is check to make sure that the actor that is overlapping the door hitbox is the player. So to do that, I guess just one thing to quickly add on this on component begin overlap node is it has all these pins underneath of it here. And the ones that we really care about are this other actor, which is the actor that has triggered this on component begin overlap event, and then the overlapped component. The overlapped component would be this open door hitbox itself. We're not going to use that, but we will be using the other actor. So one of the most important types of nodes in Unreal to learn is the casting nodes. And this is a really, really easy way and good way of passing data and checking data. So what we're going to do is create a node here that's called cast to third person character. And essentially this works similar to a branch where it takes in an input value and it checks to see if that input value is true or false, whether the cast has succeeded or it has failed. So in this case, whenever an actor overlaps the on component begin overlap hitbox, that open door box, we're going to cast it and check to see if that actor is indeed a third person character. If it is, then this action would fire. If it is not, then this action would fire. Now the difference between utilizing a cast node and just using a branch node is that the cast node gives you access to that instance of the actor that overlapped it, or whatever was casted through. So for this case, if we used a branch, we would not be able to check the specific type or that specific instance of that third person character that overlapped the door box. So just to show you this, we could do a similar method here where we could do other actor and then we could do like equals third person character. The problem with doing this method is that this checks to see if that thing that overlapped it is just third person character. It doesn't care about which third person character. Any third person character will succeed here. And the worst part is that we wouldn't know which one did it, so we wouldn't be able to utilize that data later on. With this cast node, it gives you the exact one that overlapped it. So that's really helpful for, like, in this case, if you wanted to blow the character up after they walk through the door, we would know exactly which one to blow up. But that being said, we'll just go ahead and plug this in to play. Now on this timeline node, there's these 6 different execute pins. And depending on what you're doing, you'll have to kind of adjust this. For our case, we're going to use play. And essentially the difference here from play and play from start is play will continue the animation from wherever it currently is. Play from start will always start it back at 0. So this is important for if we were going to be reversing the door afterwards. If we reverse it from end and we play from start, if you walked into the collision box after it's like halfway open, it'll just snap to close or snap to open. So we're just going to go ahead and compile that. And then don't forget, we need to drag this out. Hit play. And then we're going to run over here to our collision box. Oh yeah. So I forgot to actually adjust the static mesh part. But we have our timeline and we're checking to see if the character is there. Now what we need to do is actually animate the door itself using this data that we're getting. So we're going to drag off of the door component and type set relative location, or rotation rather, sorry. And then off of the update, we're going to plug that into set relative rotation. And essentially the way the timeline works is it has kind of this, every time it goes through like that 0.01 seconds, it fires this update. And it checks to see where that keyframe currently is on its path and what it needs to set that value to. So you'll notice that immediately, since we were using a singular float value, This float value doesn't plug into our set relative rotation. But one of the really neat things is whenever we have some of these nodes that take multiple values, we can actually break it apart into its individual values and just edit the ones we care about. So by right-clicking it, we can just split that struct pin and get all the individual values. If you want to go back to what the previous values were, you can go back and click recombine struct pin, and it'll recreate it for you. But for this case, we're going to keep it separate. But then we're kind of set with this option of which one do we actually need to rotate. And an easy way to be able to tell this is go back to your viewport here of your asset, select the object that you're wanting to rotate, and then just rotate it on the different axis. And then check in your details to see which one you actually rotated. So in our case, we rotated the z-axis. So we know that if we put the open door value into the z, it should rotate. So we'll go back over here to our third person example map. And now our door opens. Now, unfortunately, it kind of opens towards us instead of away from us. So what we could do is instead go back into here and adjust this value to -90. Or you could turn the door around or adjust a static mesh, either way. So now we can run through. The next thing is right now the door is just kind of permanently opened. And so what we want to do is add another event node and kind of utilize some of this information that we already have here to reverse the timeline after you've ended the overlap. So we're going to select the open door box, and then we're going to type in on component end overlap. So whenever the actor leaves that collision box, again, we're going to cast to make sure that it is indeed the other actor. And then we're going to plug this into the reverse node. And what that will do is we can open the door, and then when we leave the collision box, it will close the door. Yeah, that's a really simple way of opening and closing a door using timelines. Timelines can be used for all sorts of things. There's a tutorial about in that playlist series that we were talking about earlier, where it's kind of animating an object that kind of like is just like a floating pickup you'd see in like some just random video games and stuff like that, but very useful for animating any sort of static mesh. Do you guys have any questions?
All right, so let's see. I think we only have one other thing today. So now we're gonna do some, just talk about the assignment logistics. So this will be the first lesson that you actually have some assignments to complete afterwards. And now I'm just gonna kind of go through and show you like how to, get the assignment and like complete it and submit it. So if we go to the main GitHub page, and let me jump, you guys can see this like my screen, right?
Yep.
All right, just double checking. So you'll see for like each lesson, there'll be an assignment. I haven't updated it for this one because we haven't finished this live lesson yet, but there'll be some information with the links to find like these GitHub repos for your assignment. But basically, they're all going to have very similar form. They're going to be stored as a separate GitHub repo. So, for example, this is the first one. It's Unreal Assignment, Lesson 2.1. And this one is just to test some basic programming concepts and blueprints. It'll have some information about like what the assignment is supposed to teach and like how to complete it. So for this one, I'm still working on it. I got to push my commit or push the information after this, but basically it'll tell you which levels in the project you need to complete. So let's go ahead and just like look at that. It'll also have the instructions for how to start and submit. It'll be, for now, it should be pretty simple, just cloning and making a branch. So let's go ahead and do that. Like, so if I was going to do this assignment, I would take this and clone the repo. So I'm just cloning it somewhere on my disk. Okay, and then the important part is since like we talked about in the previous video, these are all binary files. You want to work on your own branch so that we're not working on top of other people. This is really important. Make sure you're not like really pushing or committing anything to the master branch. So let me just go into that. So let me go ahead and do git checkout. And just make your branch something unique. You can use your onion. That might just be the easiest way, so that we can also kind of tell whose is whose. So now I'm on my my own branch. So now if I open the project, you'll see it's just the U project. So like open that. And if you guys saw that, like we talked about in the last video, you can see that like it made the intermediate and saved folders. Okay, let's bring it over. Can you guys see this? Okay. So
Yes.
yeah, so it'll tell you like each GitHub repo will kind of like explain what to do. This one is just going to be completing some levels. So like for example, I don't know. Let's relook at the enums level. So if you open the level blueprint, there will be a comment box telling you like what you need to do. Yeah, so I'm not gonna obviously do that because I want you guys to do this on your own. But like, let's say it said print hello world, and this was my assignment to do. So, okay, prints hello world, so it's completed. So we would, I always close it whenever I'm doing stuff with Git, but you probably don't have to. So like, let's say I did that and now I'm ready to submit. Let's just double check. Okay, so we have the change. Again, don't do as I do, do as I say. Don't do add dot. Make sure you're more specific. Yeah. So git commit. Call this finished assignment. Oh. So now I have the commit saved on my local file system. And so now the important thing is we need to tag that commit. And like the introduction to Git video talked about, a tag just basically creates like a mapping of like a string, I guess, to that exact commit. And this is going to help us like just see when you guys have submitted. So for me, it would be git tag my onion and then submission. So we have some like continuous integration stuff set up. So whenever someone tags a commit with like something and then /submission, and you push that to GitHub, we'll get a notification in our like Slack channel, in the one that like me and Ben are running, basically letting us know that you submitted, and that will be the commit that we will check for your code review. So let's go ahead and tag that. And then you just go push. So you want to push your branch, and then you just want to add this tags flag to make sure your local tags are getting pushed to GitHub. So we do that. So I believe if I refresh and I go to, and the good way to see is if you go to the repo and you actually go to tags, you'll see that your tag actually is like on GitHub, and we'll be able to see it. Let's see. Sometimes it takes a second. Yeah, it hasn't finished yet. Okay. So where I'm using GitHub Actions, which is like their CI/CD tool built into GitHub. It's pretty good. Highly recommend checking it out. And you'll see I just got a bot Slack message that I have Daniel Sanchez has submitted. So make sure you tag that commit as like your onion /submission so that we get the notification and we know which commit to check out to see your like final work. Yeah. Does that kind of make sense how you would do the assignment and how to submit it? Nice and clear? Cool. And there'll be 2 assignments for this one, so 2 separate repos, and all the like where to find them will be pushed to the main GitHub page. Cool. All right. So does anybody have any final questions for the lesson as a whole or anything we've gone over so far? All right. If not, that will be the end of lesson 2.